Alright, this video is going to explain how to work velocity and acceleration problems. Right here is your velocity formula. It's straight off of your reference tables. You have v is equal to delta d over delta t. V stands for velocity. Usually it's going to be measured for us in meters per second. Delta d stands for change in position. Another way to look at change in position is simply that it's distance, like how far something traveled. We're going to typically measure that in meters. And we have delta t, which is change in time. Often that's just given to us as the amount of time. It'll say that something happened in 6 seconds, so the change in time is going to be 6. We're usually going to use the unit of seconds. Now, occasionally you will see problems that have velocity in kilometers per hour, and if that's the case, then position has to be in kilometers and time has to be in hours. The main thing is that all of the units in your problem have to match up with each other. Like, you cannot use a combination of kilometers and meters per second or hours and meters per second. Like, you've got to have the same two times and the same two distances. The other equation that we might need, and remember that this is a video, so you can pause it and you can take as much time as you need to copy information down. You can also rewind it and you can play it again if something went too fast for you. That's the beauty of the video. Our other one is this one. I messed up a little at the top, so we'll cover up my mess. Our other formula is acceleration. Pause it here if you need to while you copy some things down. Acceleration is A is equal to Vf minus Vi over delta t. The breakdown is below. A is acceleration. It's in meters per second squared, assuming that the velocities are in meters per second. Vf stands for final velocity. That means your ending velocity, where something stopped, like where it ended up at. Vi is your initial velocity. That's where it began. Where did it start out at? And then t is time. You can see the breakdown over here for the units. All of this is assuming that we're doing the typical meters per second squared. If for some reason we were going to do this problem and we were going to use kilometers, then this would end up being kilometers per hour squared, kilometers per hour, and simply hours on the bottom. As long as they all are in agreement with each other, we can make this work. So I have some sample problems for us here. Here's the first one. These are problems that, if you're in my classes, that we have worked in class together. It says that you have a car that traveled 1,025 kilometers from El Paso to Dallas in 13.5 hours. What was its average velocity? Well, I don't have a way to write on my screen currently, but we've been writing on our problems in class. I'm just going to write the things down here. Like, I see a number. I see 1,025. It says it's kilometers. Well, you're going to have to memorize your units. I know that kilometers measures distance, so I'm going to label that as D. I have a distance right there. Well, then it says that it took place in 13.5 hours. Well, that's time. And then it asks me for what is its average velocity. So it's wanting V. If I make my list like this, or if I do this by writing it up here, like if I write over the top of my problem what things are, then I can totally see that I'm going to have to put this into this equation. I'm going to be using the V equation. The V is equal to delta D over delta T. Now I can go back to my acceleration equation right here, and I can look at it real fast, and I can see, like, it's not asking for A, and I don't have two V's. Like, this is not going to be the acceptable equation. It's got to come from this one right here. To make it fit, I'll fold it down, because I have all of the pieces. I see the V, the T, the D. Once we write that equation down, now that we figured it out, we just plug stuff in. I don't know V, so I'm just going to put V back down again. D is 1,025 kilometers. I like to put the units in mine because it'll help me out in the end. T matches up right here. That's 13.5 hours. And I have no problem putting kilometers and hours together because, well, I mean, I can say kilometers over hours. That's perfectly fine. If we crunch our numbers here, my calculator says 75.9, and it's got a bunch of other digits. I've asked my classes just to round it to a decimal place if it's got decimals. So we can call that 75.9 kilometers per hour. Very simple, very straightforward. Now, if we go to my next question up here. What's the speed of a rocket that travels 9,000 meters in 12.12 seconds? Well, first thing I see is the word speed. I don't have an S. Speed is the same thing as velocity, in essence, for us in these problems. It's not got direction as a part of it, but we can still work the problems for velocity. And then it says it travels 9,000 meters. Well, I recognize meters as a unit of distance, so that's going to be my D. And then it tells me that it does this in 12.12 seconds. Well, that means that's going to be a time, because I recognize that seconds is a unit of time. Well, same way as last time, if I look at my two formulas, the only one that has these two pieces in it is the V formula, the velocity one, where it says velocity is distance over time. Well, once again, I go letter by letter. V, I don't know, so I write the V back in. My D, I do know. That's 9,000 meters. My T says 12.12 seconds. So this is really straightforward again. We just do our division into your calculator. You put 9,000 is equal to 12 divided, or is divided by 12.12. Sorry, I misspoke. I get 742.6 meters per second. I'm coming up with my unit because I've got meters and seconds. Neither one of those cancels out, so I just keep both of them. You could also write this way, meters over seconds. That's the same exact thing. There's absolutely nothing wrong with that. Both of those are acceptable. Now, let's see what I have next. I have one that gets a little bit more complicated for folks because no longer are we solving for V. This one says, how many seconds will it take for a satellite to travel 450 kilometers at a rate of 120 meters per second? Well, how many seconds is T? It's asking me how many seconds. So that's what I want. And it asked me for it to travel 450 kilometers. Well, 450 kilometers that's distance. I know that because I know that kilometers measures distance. That's the unit of length. And then it says at a rate of 120 meters per second. Well, that meters per second tells me that that is my speed. There's a couple of issues with this one. Firstly, kilometers and meters are not the same. I either need to have these things both in meters or both in kilometers. It's a lot easier to change the D, because if I change this one, I'm going to have to change a couple, it's going to look a little different. So I did this one because I knew you'd have to change it. I've taught my kids King Henry died by drinking chocolate milk. This helps me remember my metric prefixes. B right here stands for base. So this is where meter would be. This is kilo. This would be hecto, deca, deci, centi, milli. If you are at kilometers to start with, you are up here on this top step where I just drew a star, and you want to go to meters, which is at the base. So you need to come down the stairs 3 steps to land right here. Well, when you come down the stairs 3 steps, you're also kind of heading to the right on the paper. Well, what that tells you is you need to move your decimal 1 place for each stair you came down, and the fact that you're going to the right tells me where I need to move it. So what that means is 450 has an understood decimal right here at the 0. So I need to go 3 spaces to the right, which means that 450 kilometers will be 450,000 meters. Perfect. I know that I'm using this equation because, yet again, I only have V, D, and T written here on my paper. But this time I have the V. I know that 120 meters per second is equal to 450,000 meters over some number T. Well, how to solve this? Easiest way to go about it is basically to cross multiply. I'm going to go ahead and work out all my steps. I'm going to scoot over a little bit. That'll give me 120 meters T is equal to 450,000 meters times seconds. Now, I need to get this T by itself. So how to do that? I'm going to have to divide both sides by 120 meters. I need to do the opposite of what it's mathematically doing at the time. Right now I'm multiplying by 120. That means I need to divide by it to get rid of it. And remember, what you do to one side, you have to do to both. That's going to cancel out my 120s and my m's on the left-hand side. Over here, it's going to cancel my m's out, so that I'm left with just having my seconds. And when I divide 450,000 by 120, I get 3,750. Your unit is the letter that's left. It's seconds. Alright, going on to another problem. I've got several of them here for you. I have a falling objects problem. This one says you have a falling object that drops with an average acceleration of 9.8 meters per second squared. Well, we're going to have memorized that meters per second squared is a unit of acceleration. Plus, it's got this lovely word right here, acceleration, that helps me know that that is going to be A. And if it says an object falls from a tall building, how long will it take? How long will it take? Well, that's time. How long will it take before it reaches a speed of 49 meters per second? Well, the problem here is if I look at my formulas that I have to pick from, I'm not going to use this formula this time because I see an A in here and this has no A in it. It also doesn't mention distance anywhere, so this is not going to be a good formula. I'm going to keep looking, and I should see that this one is a better match because it's got an A, it's got a V, it's got T. The only issue is I don't have two V's, but really I do if I stop and think about it. If you have something that falls from a tall building, what that means is that it's going to start from rest. And what rest means is that it doesn't move to start with. You know, it's the same idea as if I pick up my pencil cap or my pen cap and I hold it right here and then I let it go. Right now it's not moving, and then when I let it go it starts to fall. So it started from rest. It started with a V of 0. That's VI because that's where it started. Plus my problem says it reaches this speed, which means this one's VF. So now I should be able to plug this in to this equation. I've got A, which is going to be 9.8 meters per second squared. If you'll write it like a fraction like this, I think it'll help you. VF is 49, VI is 0. Those are meters per second, and it's over T. So, wow, how do I solve that? Well, my suggestion would be to go ahead and clean it up a little bit if you struggle with math and recognize that this right here is simply equal to 49 meters per second because 49 minus 0 is 49. Well, now I can cross multiply. I can do 9.8 meters times T is equal to this, 49 meters per second times second squared. Okay, well, when I have meters per second times second squared, what that's going to do, maybe it would help too if I write it like this for some folks. If I write it this way, 49 meters over second times second squared would help some people see it. This one's going to cancel, and that's going to become just 1s. So now we've got this kind of a problem. Alright, how do I get T by itself? There's nothing else that I can simplify. How I get T by itself is I've got to divide both sides by 9.8 meters. Okay, well, when I divide this side over here by 9.8 meters, what's going to happen is my meters are going to cancel now, and I'll be left with seconds. Over here, meters cancels, 9.8 cancels, so I've got t is equal to 49 seconds divided by 9.8. If you carry that out, I think you get, what, 5? Yeah. That t is equal to 5 seconds. So there's my answer. Oops, it's off the screen. It's down there at the bottom. I have one more acceleration problem. If I can make it show. It says a car traveling north with a velocity of 30 meters per second. So, well, I mean, it tells me I have a velocity. It uses the word. The velocity is 30 meters per second. It slows down. So that means this is its initial speed. It slows down to a velocity of 10 meters per second. So that's going to be my final speed within 10 seconds. Well, 10 seconds is time because seconds measures time. What is the acceleration? So it's wanting me to find A. I'm back at this equation again. A is equal to VF minus VI over delta T. This may be a little bit easier mathematically because I'm solving for A. I'm not going to have to do any cross multiplication. VF is 10. VI is 30. And that will be over 10 seconds. Well, if you recognize this mathematically, 10 minus 30 is going to become negative 20 meters per second over 10 seconds. Well, then when we do some simplifying, we do the math, negative 20 divided by 10 is negative 2. And then here, you have two ways to write this. You can either write it as meter per second, or you can write it as meter per second squared, because it's the same difference. Either one of those units is the same thing and it's both correct. So you end up with negative 2 meters per second squared for your acceleration.